Today, we're doing a deep dive that feels a bit like science fiction, honestly. But it's grounded in some really fascinating physics. We're not talking about looking at your own reflection in a mirror. We're asking, what if you could somehow see the reflection of, well, another universe?
It's this idea called the Mirror Multiverse. And yeah, the sources we're digging into today really lay out some intriguing possibilities.
Yeah.
And these aren't just, philosophical games. They actually connect to real head scratchers in physics, things people are actively trying to figure out.
Exactly. So our mission here is to unpack what these sources say about this kind of mirrored reality idea. We'll get into the physics that suggests it could exist.
Right.
How it might connect to dark matter. That's a big one. Maybe even some quantum links. And yeah, even the, let's say, pretty wild idea of mirror life.
It's definitely out there.
Think of it like we're trying to peel back reality's layers, see if there's a cosmic mirror image looking back. Or maybe it's right here with us. It might just, flip how you see things.
Okay, so maybe we should start with the bigger picture first. The whole multiverse idea.
Good idea.
It's become pretty familiar now, this concept that our universe isn't necessarily the only one, that maybe we're just one bubble in a much bigger cosmic phone.
Right, and the material we looked at quickly touches on different ways physicists think about that. You've got things like the many worlds interpretation of quantum mechanics.
Where every possibility splits off.
Yeah, or cosmic inflation potentially spawning loads of bubble universes. String theory suggests a huge landscape of possibilities, too.
And then there's the mathematical universe idea, like Max Tegmark talks about in the paper mentioned, suggesting any consistent math structure might just be a universe somewhere.
But the mirror multiverse, the specific thing we're diving into based on these sources, is different, right? It's not just any other universe.
Exactly. It's specifically one that's proposed to be symmetrical to ours in some really fundamental way.
Symmetrical? How so? Like, what aspects?
The sources focus on symmetry in things like time's direction, the fundamental particles involved, maybe even the basic laws governing it all. A kind of perfect, deep reflection.
Okay, let's unpack that specific idea then. Where does this notion of a mirrored universe even come from in, actual physics?
Well, a key piece highlighted in the sources is something called CPT-symmetry.
CPT.
Right.
C is charge, P is parity.
Which is like spatial reflection, yeah.
Yeah.
Flipping left and right, essentially.
And T is time reversal.
Exactly. And CPT symmetry is this really deep principle in physics. The idea is that the fundamental laws should hold true even if you flip all three of those things at once.
So wait, if you take some physical interaction and you swap all the particles for their antiparticles, that's C, mirror image the whole setup spatially, that's P, and run the whole process backward in time, that's T.
Then the physics, the underlying rules, should look exactly the same. That's the prediction. It's a very powerful symmetry.
And that leads?
Well, it leads some physicists, as our sources describe, to propose something pretty radical. If our universe exists, maybe a CPT-symmetric partner universe should also be possible, or maybe even necessary for the symmetry to hold overall.
A partner universe.
Yeah, and the really mind-bending part is that this partner could be a universe running essentially backward in time from the Big Bang, mirrored in time, charge, and space compared to ours.
Wow. Okay, so it kind of balances the books, cosmically speaking. Satisfies that deep symmetry.
That's the idea. And here's where it gets really interesting, connecting to things we might actually possibly see. The sources point to the ANITA experiment.
Ah, yeah, the Antarctic Impulsive Transient Antenna, that balloon flying over Antarctica.
Right, designed to look for cosmic rays, neutrinos, and around 2020, it detected some really weird events. These upward-moving cosmic ray-like signals.
Which is strange because cosmic rays usually come down from space, right? They don't usually come up out of the Earth.
Precisely. It's highly anomalous. And the analysis discussed in the sources suggests these events are hard to explain with standard physics. They might require new particles. Or one interpretation, put forward by people like Boyle, Finn, and Turok in work mentioned in the sources, is that maybe, just maybe, these are faint signals from that proposed CPT-symmetric time-reverse universe interacting with ours.
Okay, that's a leap, but fascinating. Thinking about that ANITA data, it makes you pause.
It does.
Like the sources ask, if time flows backward there, do they remember tomorrow instead of yesterday? That just completely flips your perspective.
It takes this abstract symmetry idea and, very speculatively ties it to something observed.
Okay, so that's the time reversal angle. But the sources bring up mirrors in another big area of physics, right? dark matter.
Exactly. Another huge mystery. We know something massive is out there.
Yeah, holding galaxies together, shaping the cosmos through gravity, but we just can't see it. Doesn't seem to interact with light.
Right. So one theory presented in the sources is that dark matter isn't some totally new exotic particle within our set of forces. Instead, it could be made of mirror particles.
Mirror particles? You mean like mirror versions of our regular particles?
Kind of, yeah. The sources give examples like mirror electrons, mirror photons, even mirror hydrogen atoms. The idea, explored in work like Robert Foote's mentioned in the source material, is that these particles exist in a sort of parallel sector.
A parallel sector.
Yeah, like a whole separate set of particles and maybe even forces that mirror ours. They wouldn't interact with our light, our electromagnetism, or the strong nuclear force the way our stuff does, so they'd be invisible to us, basically.
So if they're invisible, how would we ever know they're there, according to this mirror matter idea?
Gravity, that's the key link proposed. They would still have mass, so their gravity would pull on our matter and our gravity would pull on them. That's how they'd shape galaxies and clusters.
Ah, okay, so gravity kind of bridges the gap between our sector and the mirror sector.
That's the main proposed interaction. There's also some speculation, mentioned in the sources, about very weak interactions, maybe through something called neutrino mixing.
Neutrino mixing. That's where different types of neutrinos can change into each other, right?
Exactly. It's a known quantum phenomenon, and it suggests neutrinos might, just possibly, offer a tiny window or bridge between our sector and a mirror one. But mostly, it's gravity.
What's really fascinating here, thinking about what the sources imply, it's not necessarily that this mirror world is like light years away in some other dimension.
Right.
It could be right here, coexisting with us, interpenetrating our space, but just out of reach for most interactions.
Exactly. Hidden in plain sight, in a way. Making up all that gravitational pull we call dark matter. That really changes how you think about parallel universe, doesn't it? Less distant, more adjacent, but invisible.
It really does. Okay, so we've got time reversal, dark matter. What about quantum mechanics? The sources mention connections there too.
Yeah, the quantum world is where things often get weird, and mirror concepts pop up there too. Entanglement is a big one.
Quantum entanglement.
Yeah.
The spooky action at a distance.
Right. The sources describe it pretty well. It creates these non-local links. Like you have two particles, you measure one, and you instantly know something about the other, no matter how far apart they are. Like they're connected by an invisible thread or mirrors reflecting each other instantly.
So how does that connect to a mirror universe?
Well, the sources raise some pretty speculative questions here. Like, could entangled particles in our universe somehow be linked, maybe fundamentally, to their mirror counterparts in this other CPT-reversed or spatially mirrored universe?
A connection across universes via entanglement.
It's an idea. Another one mentioned is trying to explain quantum measurement. You know, how a quantum system seems to randomly pick one reality when we measure it. This wave function collapse.
Yeah, that's always been a puzzle.
Some theorists wonder if maybe that choice isn't random, but is determined by hidden information, hidden variables that might exist in a mirrored dimension. Like the measurement outcome here is linked to something happening over there.
So these quantum mirror models, even though they're very much theoretical, what puzzles are they trying to solve, according to the sources?
They're trying to tackle some deep quantum mysteries, things like why the wave function collapses, those tricky measurement paradoxes,
Right.
and maybe even the arrow of time itself. Why does time seem to flow only forwards for us? Perhaps it's related to this fundamental symmetry or an interaction with a time-reverse sector. It connects back to ideas from people like Sakharov, mentioned for his work on cosmic asymmetries.
This raises a really important question then. Could the very act of measuring something in quantum mechanics, or even the direction time flows, be like reflections of an interaction with this hidden mirror reality?
That's the kind of deep question these ideas provoke. It suggests our perceived reality might be intertwined with something else in ways we don't fully grasp yet.
Okay, let's push it. The sources go even further, right? Into the realm of mirror life.
Ah, yes. That's definitely the most speculative territory we get into. If a mirror universe exists, with mirror particles obeying similar, maybe CPT-reversed laws, could life arise there?
Seems like a massive leap.
Yeah.
What are the problems? The sources must list some big challenges.
Oh, absolutely. Huge challenges. For starters, chemistry could be totally different because of chirality.
Chirality.
Yeah.
Handedness. Like
Yeah.
left-handed and right-handed molecules.
Exactly. Life here relies heavily on one specific handedness for things like amino acids and sugars. Mirror chemistry would use the opposite hand. Could complex life chemistry even work that way? We don't know.
And the time reversal thing.
Right. If time is literally flowing backward, could complex structures that rely on building up history and memory like brains or even just evolution itself actually form? It's really hard to conceive. Evolution might follow completely different, maybe non-biological paths.
This is pretty unlikely then. Almost impossible.
The hurdles are immense, but
Yeah.
the sources do offer a slight counterpoint, just that the fundamental laws of physics, even if CPT reversed, might still permit stable mirror atoms, energy to flow, and the kind of thermodynamic order that could, in principle, allow complexity to emerge. It's not saying it would happen, but maybe the basic physical requirements aren't totally forbidden.
So not completely ruled out by physics, just extremely difficult to imagine.
Precisely. And then there's this other cool idea the sources mentioned. Crossover moments.
Crossover moments, like the universe is bumping into each other.
Sort of, yeah. Brief instances where maybe our universe and a mirror universe could interact more directly or brush against each other gravitationally.
And if that happened,
Yeah.
could we see anything? Would it leave a trace?
The sources speculate, yeah. You might look for things like weird gravitational anomalies, places where gravity seems off, suggesting mass we can't see. Or maybe it contributes to the missing mass issue on larger scales, perhaps even leaving marks like unexplained cosmic cold spots in the microwave background radiation, remnants of some ancient interaction, faint whispers.
If we try to connect this all together,
Yeah.
it's kind of humbling. If there is mirror life out there, made of mirror particles, they wouldn't see us either, right? Using their mirror light.
Presumably not, no.
But maybe they're wondering about us, the other side of their cosmic mirror.
It certainly provides a sense of symmetry, doesn't it?
Yeah. So, okay, let's recap. We've dug into these sources exploring this really wild idea of a mirror multiverse.
Yeah.
Not just any parallel world, but one potentially defined by deep physical symmetries like CPT, maybe running backward in time.
A place that could be hiding the universe's dark matter right under our noses as mirror particles.
Linked perhaps through quantum entanglement's weirdness.
Yeah.
And yeah, even potentially hosting mirror life with maybe faint hints of cosmic crossovers.
And these aren't just random guesses. They stem from trying to explain real observations, like the Anita events, or fundamental puzzles like dark matter and quantum measurement, using principles like CPT-symmetry.
It really pushes against our standard picture, suggesting maybe what we see is only, half the equation?
That there might be this whole symmetric counterpart reality hidden from us.
Which brings us back to those big questions from the sources. Is there some reversed version of you out there? Thinking backward in time, is our universe really the whole story? And what would it even take to properly peer through that cosmic mirror, scientifically?
It really underscores how much we still don't know about reality at its most fundamental. The search is definitely ongoing.
And that leaves us with a final thought, maybe building on all this. If reality does involve these kinds of symmetrical structures, these mirror universes, what does that really mean about our own existence, our own nature? Could figuring out the reflection actually be the key to truly understanding the original?
It's a profound question. Does understanding the symmetry unlock the whole picture?
Something to keep wondering about for sure.